All right, so for B, I'm actually going to do this one with Bolzano's theorem, just because there's no numbers here, right? So solving it with IVT would actually be Bolzano's theorem because like f of c would equal 0. So I'm going to get everything over to one side, right? So I'm going to say x squared minus x minus cosine of x is equal to 0. Now, again, if you want a more detailed kind of like write up for this next part, just check out the other neater notes. But we would say that here's our f of x. And we know that f of x is continuous for all real numbers because x squared minus x is continuous for all real numbers of polynomial, and cosine of x is continuous for all real numbers. Right, so then since we're on 0, pi, since we're using Bolzano's theorem, we want to show that one endpoint is going to give us a negative value and one endpoint is going to give us a positive value. So let's just find f of 0, f of pi. So f of 0, 0 squared minus 0 minus the cosine of 0. That's going to be 0 minus 0 minus 1. Cosine of 0 is 1, so negative 1. F of pi, we're going to get pi squared minus a pi minus the cosine of pi. All right, so let's see, pi squared, I don't know, like 3.14 squared, so it's like 9 and some change. 9 and change minus 3 and change minus, well, cosine's never even bigger than 1. So I don't even care what that number equals. I just know that it's greater than 0. You could throw it into a calculator if you want. If that makes your heart happy, by all means, do that thing. Bring your heart joy. So then, since we know that one endpoint is negative, or one endpoint has a negative y value, one has a positive y value, we would say, as kind of our conclusion, since f of x equals x squared minus x minus cosine of x is continuous on 0 to pi, there exists a value c in this interval, 0 to pi, such that f of c is equal to 0. Put another way, that's like saying that c is a solution, c is a root, c is an x-intercept. All of those things work in terms of language.